Alright, hello and welcome to week 3 of NTI, linear functions and slope. We are discussing slope as a measure of change, and we're going to be using that slope in equations of lines. So you might remember y equals mx plus b as the equation of a line. This is pretty well understood. In fact, it's the easiest way to graph an equation of a line. However, you just need to make sure that there's a degree of 1 on the variable, and that's how we're determining if we have a linear on the leading variable, and that's how we're determining if we have a linear equation. So something we are going to have to do in this lesson is determine the slope given 2 points, and this is a pretty standard skill for those of us going into calculus, because we'll build on that idea and use it to describe more complicated functions and features of graphs with derivatives. So I'm just going to take us through the basic formula of slope in case you forgot. This is really something you should have in your back pocket at all times, especially going into calculus. So this will get us through the first piece of the puzzle, is finding that slope m. B is equal to, let's see, I'm adding 30, so 29. B is equal to 29. So my final equation is going to be y equals negative 10x plus 29. I wanted to show you all a different way of determining the equation of a line, and that's using the point slope formula. This is pretty useful because we get all of our work done with slope and the y-intercept done in one go. Determining the equation of the line using point slope might be a little quicker than determining it with slope-intercept form. So there's two ways to get the equation of the line passing through 3, -1, and 2, 9. So this line passes through -2, 6, and we've got a slope of -1/3. And we're going to determine the equation of the line. I'm going to use the point slope version of a line to go ahead and set this line up in a good format, so I can isolate y and get these variables to look like a line. And there you have it. I got my equation of a line. Okay, so a secant line is pretty important to us in calculus because it's determining the average rate of change, and this line is pretty easy to see because it's going to look like it cuts through the curve of the graph. So this average rate of change gives us a general or like a sweeping statement about the function we're observing. So what we've got is a polynomial function that is defined on the interval -2 to 3. So this polynomial function, if we can zoom out a bit, is defined from -2 to 3, and those intervals are creating, we're determining the secant line from those intervals. So I'm going to draw a closed dot from -2, x equals -2 to x equals x equals 3. So this is the line we want to determine. We want to know this equation of a line so we can determine maybe a trend in the data we've found. So in order to figure out what the y values are, I'm going to have to evaluate my function f at -2 and f at 3 to determine what the y values are. It's pretty evident from the graph as well. I can see those points on the graph. So this data right here is crucial to figuring out what the equation of a line is, because all you really need for a line is a point and a slope. So we'll have to use these 2 points to determine the slope. So let me do that real quick. We have our slope and the equation of our line. I'm going to use point slope here to determine the equation of my line. So we got y equals 3x plus 6 plus 4. So my final answer is y equals 3x plus 10. Alright, so the last thing I wanted to show you was this square root function defined on the interval as well. And we'll be determining a secant line that spans the width of this interval. If I can draw a straight enough line, let me try again. And it determines the average rate of change from 1 to 13. So we'll just be evaluating this function at 1 and at 13. There we have our building blocks, and it's important to note here that I'm labeling everything. So I'm telling myself that the output when I put in 1 as my input is 1. The output for 13 is 5. And that's going to be really important when you're describing things in mathematics terms, because other people can read it. And that's what you're going to have to do in calculus. So we'll use those 2 y values to determine the slope and equation of the line. That's how I'll determine my equation of a line. So I'll end up with 2/3. Thing I wanted to mention is the slope of 0 versus an undefined slope. An undefined slope is a vertical line, and then slope of 0 is a horizontal line. So when you're looking at these things, you really want to have them differentiated in your head. A slope of 0 does not mean there's no slope there. The slope is 0. It has a value. An undefined slope means there is no value. So we can't say that there's a slope present in an undefined slope situation. That should be helpful for our first week of review. You'll see similar questions on quizzes, and I look forward to seeing you all this week. See ya.